Hi everyone. I want to talk a little bit about voltage, resistance, and current. Voltage, resistance, and current in electrical circuits. I know we talked about this the other day, but I'd like to review because it's been a couple of days to make sure that everyone remembers. Okay, so before we talk about these, let's first talk about how a circuit works. So I'm going to use this simulation software to show how a circuit works. In a circuit, there has to be a power source, like a battery, and I'm going to build a circuit that has just a battery and a light bulb and a few wires in it. Okay, so we learned the other day that circuits need to be closed in order to work. What does it mean for a circuit to be closed? For a circuit to be closed, there has to be a continuous loop where everything is connected so that the charges can flow all the way around the circuit. You see, once I connect it, they start to flow. They move through the filament of the light bulb and back out the other side. And as a result, the light bulb lights up. Okay? Okay, so the reason the circuit works is because the battery here is pushing the charges through the wires, through the bulb, and back to the battery. This is because a battery provides voltage for a circuit. Another word for voltage is electrical potential. Electrical potential is the potential for charges to do electrical work. A battery has potential because the positive and negative charges are separated on either side of the battery. These charges want to get back together. Remember that positive and negative charges don't actually want to do anything. I'm just saying that. Okay, so they can't get back together unless the circuit provides a path for them to get from one end of the battery all the way around to the other end of the battery. So they have all this energy, they really want to go, and once you give them a path, they go. Okay? Now, if there's no real resistance in a circuit, this word resistance, the charges will flow extremely fast. Let's see how that can happen. So if I take this light bulb out of my circuit, removing the light bulb, and instead I'm just going to connect this wire right here, look what happens. It says animation speed is reached. They're actually slowing down the simulation speed. So the charges are moving so fast we wouldn't be able to see them. And what's happening here is that these charges have all this electrical potential and there's nothing to slow them down in the circuit. So by the time they get back to the battery, they still have all of their energy, and all of that energy is spent just heating up the battery. That's really wasteful, and it's also really dangerous. This is called a short circuit, and short circuits are what cause electrical fires. They are bad news. Okay, let me split this up. Now the circuit is open again, so it doesn't work. It only works if it's closed. Okay, electrical devices, like a light bulb, need that electrical potential so that they can do their jobs, right? They need energy to do their job. Just like a light bulb, its job is to light up. It needs energy to light up. The battery has the energy. The wire brings the energy through. So, as these charges now give their electrical potential, their energy, to the light bulb, they get more tired, right? So they don't move as fast because they're using up their potential to light up the light bulb. So when there's more resistance in the circuit because of a device that's using the energy, the charges move slower and slower. Okay? In simple terms, what does all this mean? This means that adding more batteries increases the voltage, the electrical potential. So charges move faster, current increases. Okay, so if I add another battery to this circuit, like this, boom, the charges move faster, the light bulb gets brighter, more energy is being used to light up the bulb. Okay, on the other hand, if I go back to my original setup with one battery, and now I add another light bulb, the resistance is going to increase, and the two bulbs will get much dimmer than the original bulb, and the charges are moving slower and slower and slower. So again, adding more resistance causes charges to move slower, so the current decreases.